Hello, everyone, and my name is Mesut Turkal. I'm very happy to be here, a part of this amazing conference. And as Andrea already told, I'm based in Tokyo. Originally, I'm from Turkey, but I'm living in Japan for 2 years, and I'm working here as well. And again, I'm a quality assurance engineer, and mostly I'm doing some quality assurance activities, including designing test cases and executing them, and of course, some other activities like bug bashes or dog fooding activities, just to improve or just find ways to improve the quality of our products, or even improve the quality of the processes in which we develop our products. And in this session, we will a little bit talk about the bugs, because I believe whoever involved in the software development activities are somehow having some interactions with the bugs. We are maybe finding them, reporting them as the testers, as the quality assurance members, or even as the developers. Sometimes we are finding bugs and reporting them, and then we try to fix them. Or maybe sometimes we just watch them, just observe and add them into watch list and try to observe what happens in the later stages. And we do the triage and we do lots of several interactions. So the main idea in the session will be just interacting with the bugs and talking to bugs. What do I mean by talking to bugs? Do bugs speak? Yes, they do. So I will explain what I mean by this, and we will try to find several ways to communicate to bugs. So, managing bugs may give us some benefits in two different perspectives. First of all, on the one hand, of course, if it gives us a chance to improve the quality, because when we find some bugs, it means that we are revealing some weaknesses or maybe even vulnerabilities in the product, and we are trying to remove them. We are trying to eliminate those weaknesses. So, which means we are trying to improve the quality. But on the other hand, looking to a bigger picture might give us a chance to collect some insights about, for example, when we analyze the bugs, we can understand lots of different insights. For example, what kind of bugs we are mostly having, like, or on what kind of features are we mostly having some bugs? What kind of features are more prone to errors, or they are more flaky, they are more fragile when we try some corner cases or boundary values, on what kind of use cases we are having some bugs. Those kind of different categorization or clustering activities we can do, and we can collect lots of different insights. And after doing this analysis work, we can maybe have some action items to prevent those weaknesses to happen in the later stages again and again. Because finding bugs is good, because in this way we can improve the quality. But how about avoiding them in the first place? What if we already eliminate them even before releasing to production? That would be already a better approach, and we will be already eliminating or at least reducing the costs to maintain these products and the features of the product. So, to do this analysis, or maybe to collect some insights, collect from information, we have to talk to them, right? What I mean is, we have to listen to them, because bugs have lots of different information. They have lots of different stories to tell us. But if we are able to listen to them, if we communicate to them in the proper way, then we can collect lots of different information. Otherwise, if we are not listening to them, if we are not paying attention to what they are saying or what they are trying to say us, then even if they are talking, then we would not be understanding them, because we are not listening to them at all. So we should pay attention to them, and we should try to find a way to communicate to them. We should try to learn their language. So in this way, we can do a proper communication. Let me a little bit try to convince you about sharing some stories and the examples. This part will be just like a storytelling. So I will share a few experiences that I had, in which I tried to communicate to bugs, in which I had some lessons learned from different bugs. The first story is, after having a long and tiring root cause analysis, we figured out that the root cause of the problem was already a known issue. It was an old bug, already open for a long time, and no one take care of attention on that bug because it was just opened. And at the time that the bug was raised, it was not high criticality. It doesn't have too much critical consequences. So we just put it in the backlog. And after that point, no one took care of them. We did not add it to the watch list. We didn't continuously track the situation. And eventually, there was some other side effects. And eventually, it resulted in a critical consequence. So the lessons learned in the story from my perspective, what I learned from this old bug, which were sitting alone without having any attention from anyone, was even if the bug is not high criticality at the moment that it was reported, it doesn't mean that we can forget it forever. So what we can do is maybe even though we will not resolve it immediately, it is very normal because every bug doesn't have to be resolved immediately because there are the priority lists and maybe we have some other urgent tasks to do. So it's okay to put it in the backlog. But what we can do is we can continuously watch and try to understand if after some other development activities the criticality or the maybe the priority or the severity changed or not, and after some point it starts to be higher priorities, then we can start to resolve them. Otherwise maybe we will have some critical consequences in our production environments. And then in another example, we realized that some bugs, some different groups of bugs, were raising or disappearing together. For example, whenever we have some functional issues on our gateways, then we were having some, in the meantime, having some security issues as well. Those were kind of appearing and disappearing together. Or like if we have some functional issues when we are not deploying the load balancer services properly, then we were having some performance issues as well. So these kind of different types of bugs or groups of bugs were aligned together. They were kind of related to each other. So what we can do is, if we somehow figure out these kind of relations between different groups of bugs, then whenever we find some of them, we can already pay attention to the others, and we can already be aware that some other related bugs may appear. So we can already apply some preventive action items to avoid those other related bugs. And the final example that I will share is the sweet escape, which is the story of an escaped bug, which means normally we are trying to keep our bugs in our testing environments, and we don't want to them to let them go in production environment. We don't want them to meet with our customers because normally we try to find them in the early stages, which is like the development stages or the testing stages. But if they go somehow to the production environment, then it will be much more costly for us to apply the fix because it will be already in the working functionality. So applying the fix will be much more difficult, and maybe it will be already too late to change the behavior because the customers would be already using those behaviors. So when I talked to this bug, the escaped bug, he told me in which way he escaped to the production environment. Because normally I thought that I designed some test cases and I covered all the use cases. And that was true. I designed lots of different test cases. But the missing point was I did not cover or execute these test cases, design test cases to cover the specifications with the correct data inputs. So, for example, let's think about an upload feature. And if different types of data is supported to execute this use scenario, for example, you can use some integer values or even you can use some string values. So if you test this or if you execute this scenario with only integer values, you will never be sure that it will work with string values as well or not. So you should improve your coverage with the correct data. So maybe you can apply some different approaches to improve the coverage, like maybe boundary value analysis or equivalence partitioning, or maybe we can even do the test or data driven testing. And in this way, we can somehow try to improve the coverage. But what I mean in short is, as a result of all these stories, if we talk to bugs and ask the correct questions, they will definitely give us some answers. And if we try to listen what they are saying, we will tell or we will get some stories from them. we will get some lessons from them, and we can utilize these kind of lessons learned in the future activities, not to have the same issues again and again continuously. So of course, talking to bugs is possible, but of course we need some base rules to maintain a communication channel. For example, again, I want to illustrate this issue with a real life scenario. For example, when I'm sitting in the airport waiting for my flight, if there is an important announcement that has to be notified to the passengers or the customers waiting for the flight, then the airline companies need some communication channels, right? They have to make this announcement in different ways. For example, they can use some screens to show visually, or of course, they can make the announcements in a verbal way. So they can use speakers, and we can somehow see or hear these kind of announcements. But if we are not able to see it, or if they don't have any screens at all, and if they are not announcing it in a verbal way, then maybe we will not see it, we will not hear it. So maybe I will miss my flight, right? Because I will not know that the flight is changed, or maybe the gate is changed. I would be still waiting in the wrong gate. This is one important aspect of maintaining the correct communication channel, having the correct environment or having the correct communication channel. This we can phrase as tooling as well, just using the correct tools or platforms to transmit our message. This is the first thing. And the second thing is, of course, we have to use the correct format, right? For example, like if the announcement is made in a language that I did not know at all, for example, if I don't speak French and they are saying something in French, I would know that there is some information, but I would not understand what it is. So I would not get the context. So the data transformation would not be successful, and the formatting and the protocols or the other messaging ways would not be proper to transfer the message. And finally, even if we are using the correct tools, or even if we are using the correct formats, if data is noisy, then still I would not be understanding what they are saying. They are speaking in English or the native language that I'm speaking in, and I can understand normally if the data was clean, and I can already hear it. They are using the correct speakers, and I can hear, but still I don't understand because there is too much noise. So cleaning the data instead of using the raw data, doing some data processing like data mining, and then eventually coming up with some clean data is the last important aspect of having some information from the bugs. Of course, this will not be only the illustration, but I will share some real life scenarios where we do the data processing on the bugs from our projects as well. So first of all, let me give some examples regarding these preparations. And after the first part, I will give some different kind of information that we can collect from the bugs in the second part. So first of all, we said that the environment or the tools that we are using should be very clear and visible. For example, this is on this slide, we can see a sample life cycle of a bug. It is starting from just after it is reported. It is in the new status, and then maybe we assign to someone, we do the triage, and then after someone starts working on them, it would be in progress, and eventually it will be fixed, and after verified, it will be closed. This is the ordinary life cycle, or all the state transitions starting from the creation until the closure of the ticket. But of course, sometimes it would not be going through all these steps, but sometimes it would be rejected from the first place. They would decide that it is not a bug at all, so they would reject. But if I do not use this state transition, for example, if I'm using the default template from the tool that I'm using or the issue tracking system that I'm using, it would be maybe only a few steps, like including new, in progress, and closed. If I use this default template, then I would not be understanding whenever a ticket is closed, why it is closed. It is fixed and closed, or just decided to be rejected. It would be decided as not a bug. and then closed. I would not be differentiating these two different situations. So the important thing here is I should customize all the environments and the tools that I'm using to improve the visibility as much as possible, the the transparency of representing all the status that I'm performing. And after that, what I can do is, as the next step, after preparing the environment itself, I can automate some monitoring activities because doing all these queries all the time manually is not easy. Think about every day I'm trying to get the updated results manually. Each time I'm going to the navigating to the URL and preparing the queries, the filters manually, and getting all the results, parsing them manually. It is really not easy and too much wasting time. So instead, what I can do is I can already develop some scripts to do that. So by executing those scripts automatically, I can already periodically run these jobs, and it can already send these queries every day. And after getting the results, it can already parse the relevant information, and I can transform this information into some more reasonable platforms or the environments. So, what would be the reasonable platforms to understand this information? Because when we get the information from this box, we get the raw data. It is great. Numbers are great, and they are saying us a lot of information. But how about if we transform them into some visuals? Like I can use lots of different graphs or charts, and in this way, I can even more easily understand what's going on in my environments. For example, if I use some line charts, I can understand the trend is going higher or lower. The numbers are increasing or decreasing. But just trying to understand the reading the numbers from the raw data is not that much easy and not that much straightforward. But transforming them into some dashboards and some different graphs and visuals would give us a chance to do the analysis in a much more easier way. So the first part was just what we need to communicate to bugs and what kind of preparations we can have. And if we have all these preparations, then what kind of information we can collect? Let's a little bit talk about this in the second part, the information underlying all those bugs. So in this part, I will share lots of different samples of graphs and charts, and we can try to do lots of different analysis. For example, starting from the distribution of bugs across their status or across their severity levels. For example, when we show the distribution or the percentage of all the status, we can easily see what percentage of the bugs are still open, are still not in progress, or not even still closed or verified, but still open. Or what percentage of them are still in progress, and which percentage of them are still waiting to be verified. They are fixed by the development teams, but they are still waiting to be verified by the QA teams or the QA members. So this status distribution will give us a chance to see the overall distribution of the status of the bugs. And in addition to that, we can show the distribution against its severity levels. In this way, we can understand we are having mostly high criticality bugs or low severity bugs. And severity analysis may depend on lots of different aspects. For example, what we are doing in our projects is we are deciding the severity levels of the bugs based on two different dimensions. The first one is the visibility, and the second one is the criticality. For example, whenever we have a bug, whenever we have an issue, how critical it will be. Like it will make all the services down, there will be a downtime, or there will be even some legal issues regarding the clients or customers. This is the first aspect. And the second is the visibility. For example, even if it is not a high criticality, it is maybe only a cosmetic issue. But if it is like a very visible text in the main page, like it is even more important for the mobile apps. Whenever you go to the main page, it is a quite big text, and you have a typo over there. You could not write your brand, for example. Your logo is wrong. Think about this. It is a really big prestige issue, even though it is not high criticality, since it is very visible to the end users. So this should be still high priority. So we should not consider the severity based on either of this, but we should consider two different aspects in the meantime, and we can come up with the proper severity levels. And eventually we can show which of the bugs are the high priority or high severity, or which of them are low severity bugs. And similarly, we can show some different distributions among different dimensions or aspects or the of the bugs. For example, the service or the component or maybe the subsystem of the system on which the bugs are found. In this way, we can figure out, we can understand which part of the system are more fragile, which parts of the system are more prone to errors. For example, if I have lots of different services, but most of the bugs are raised on a specific service. For example, half of the bugs are in the sprint, half of the bugs are coming from a specific service, even though I have 20 services. So in this way, I can understand there is something wrong on that specific service. Maybe they skipped executing the test cases. They missed just executing the tests, and they did not deploy their service properly, correctly. So I can understand these kind of root causes, and I can maybe warn the relevant teams or the responsible people to take care of their service or the component that is being developed in those teams. And one other categorization can be based on the type of the bug. For example, if most of the bugs are functional bugs, or maybe mostly we are having some security bugs. So in this way, we can understand which type of test we should improve. For example, most of the bugs we have in the sprint are coming from the security typed bugs. Then maybe we should add some more security tests. Maybe we are not having enough security tests to find the security vulnerabilities. Or if we have some other type of bugs as a dominant type, then we can try to improve our test cases in those specific type. So not only the pie charts, but of course we can show some trends or the bar charts as well to understand how our progress is going. For example, how much bugs we are finding each sprint or each certain periods. And in this way, we can understand if there are any anomalies, like we can understand what is our average number of finding bugs or maybe having bugs. And then if any certain sprint, we are having too much bugs or maybe too less bugs, then we can try to understand what is the root cause for this anomaly. And after finding the root cause, we can take the relevant action items. And similarly, maybe we can show the resolution duration as well, because not only finding the bugs, but also time to fix is also very important. Because if we have some critical bugs, of course, finding them is very important. Otherwise, they will live in production. But even after finding bugs, until we fix it, we apply the fix, the bug will be still there. So the resolution time is also important. How quickly I'm resolving these issues. This is one thing, but another important metric related to this aspect is how maintainable code I'm writing. Because if the code that I'm deploying is not maintainable, maybe the resolution duration would be high. So I can try to improve the maintenance or the maintainability of the code that I'm deploying. In this way, I can try to reduce the resolution duration of the issues. But as a general heads up, whatever metric or whatever monitoring aspect we are trying to collect, only sticking to these individual metrics can be misleading. For example, if I'm just following the number of bugs I'm finding, let's say I'm finding 5 bugs in the sprint, what does it mean? Maybe it doesn't mean anything. So this individual metric might be misleading or might be even nonsense, because this individual metric itself would not be meaningful. But if I do a comprehensive analysis, not only the number of bugs that I find in this sprint, but if I do the continuous monitoring and I can continuously track if it is increasing in time or decreasing in time, and maybe not only this metric, but combining with some other metrics. For example, when I when I propose some new approach to improve the quality in my processes, then I can observe if those proposals will some effects on this matrix, then those metrics would be beneficial to me to understand if my proposals are contributing to improve the quality or not. Otherwise, if I just get the numbers, I get $5 in the sprint. So what? Then what? It doesn't make any sense, or it doesn't have any meaning. So these metrics should be used in a smart way to understand different ways to improve the quality of our product, or even to improve the quality of the processes in which we are developing those features or the products. And then, of course, we can show the created versus result bugs. And in this way, we can even understand the gap between the created and the result. And if we realize that the gap is increasing in time, so maybe we can have an action item, which is like, let's stop the developing new features. Because first of all, let's reduce the technical debt, right? Because it is increasing in time all the time. So if we still try to continue to develop some new features, we will even have more bugs. So maybe it's time to stop for a while. First of all, get rid of all the issues that we have, at least the critical issues that we have. And when we reduce the gap, then we can continue with some further feature developments as well. And finally, we discussed that we can use some pie charts or even bar charts or trend charts. But of course, we can use some tables as well to do some different categorizations. For example, we discussed about showing the distribution of their severity levels. But how about severity levels in different ages? For example, when speaking in terms of the high criticality bugs, maybe it is very important to see if there are too old bugs, which means it is open for a long time. Then we can try to understand why it's open for a long time, because normally it's high criticality, which means it should be a high priority, but it's still open for a long time. So then we can try to check the history of the bug and try to understand why it is not still resolved, and try to understand the impediments to resolve these bugs. And one more thing we can show is maybe there would be some bugs which are already fixed by development teams, but still not verified by the QA teams. Then in this case, we can go to the QA teams instead of the development team and ask them, guys, there are still bugs waiting for your approval. So please go and verify them, because, you know, whenever some bug is fixed, it doesn't mean that we can immediately close. Sometimes the fix doesn't work. So we have to verify that the fix is already working or not. So we need a verification on the bugs to close. And finally, last but not least, definitely not least, is the tracking the escape bugs, which is the bugs which are not found by the test cases. Because how can we understand how strong our test cases are? How can we understand the health of our test cases? We use some different metrics, like, for example, test coverage or automation coverage. Great. I have 100 test coverage, 100% test coverage. But how well designed those test cases are. For example, I can cover all the specifications very well, but my test case are not asserting any expected results. I just added a few test steps to cover the behaviors, and they're not really catching the real issues. So this is the quantity versus quality, right? Again, the main idea should be, we should not stick on just numbers, just metrics. Tracking the test coverage is great, okay, but that should not be the only and only metric that we are tracking. So maybe we should try to find ways to measure the quality of test cases as well, in addition to their quantity. So one metric that we can get some insights, still it would not be sufficient itself to understand the health of the test cases, but it would be just a metric to get some insights about the quality. We can track the number of escape bugs which are not found by the test cases but reported from the production environments. And last part, I'm getting close to the end of presentation, but this part might be considered as a bonus part, which is, we are talking about managing the bugs. So how about try to manage them with the help of AI algorithms, machine learning algorithms? Like, can we manage bugs with an ML assisted way? Let's see how we can do that. I tried this in my real life project. And I will share some results, how it looks like. So the main idea is doing the categorization. It is just a classification problem. So normally we are doing the bug triage, right? And doing the correct triage is very important. Because if I label one of the bugs with a lower priority than it should be, for example, normally it should be a high priority, but somehow I label this with a low priority. So which means I will be postponing the fix. I will be delaying the immediate fix. Or other way around, if I'm labeling a bug which should be normally low priority with high priority, then maybe I will try to fix that immediately because I will think that it is high priority. But it will be blocking some other urgent issues since I'm doing the triage in the wrong way. So doing triage is very important. And the idea here is if I'm doing a triage myself as a human being, then what I would do is when I find a bug, normally I report it and I make my own consideration. So for me, maybe it is severity 2, let's say. But for someone else, it might be severity 3 or 4. So it might not be consistent all the time. Because when I'm raising a bug, personally, I'm not checking all the other bugs raised by other people to have a common understanding. But if we let the machines do this triage, the machines can analyze all the data very quickly in microseconds, maybe. So it will be much more consistent. So the idea in this problem is trying to do the estimation of the severity levels of the bugs after learning how all the existing bugs are triaged. So in this case, I studied on almost 900 bugs. I exported them from Jira. And normally I have the description of the bugs, and then I have the severity levels. So these are the training sets. After reading the description and after I read the label, then for the upcoming bugs, I would make an estimation. After I read the description, I would try to doing the label by the machines. And in this way, the steps that I'm following is first of all, I do the pre-processing, just get rid of the unneeded words or some other information from the descriptions of the bugs. And then after this pre-processing and the cleaning of the data, of course, in an ordinary machine learning algorithm, we should do the feature extraction. What it means is, I'm just when I'm doing when I want machines to do the bug triage, I'm giving them some bugs, which is like just some string values, some texts written in the language, natural language that we are using. For example, most of all, we are reporting them in English, right? But machines don't understand this language. So we have to convert these string values into some numbers, some numeric vectors. So this is basically the feature extraction. So the sentence should be converted in a numeric vector. And after this, this would be my features, and I will provide these features instead of the raw sentences to the machines. So how I do is I use the bag of words algorithm for this. So basically, it counts the frequency of the words in a sentence. It just counts. And for example, there's a sample sentence on the slide, which is this is an apple. So in the sentence, this word is happening one time, is the frequency is only once, and is again once. And in the whole vocabulary, of course, there are some different words. Maybe they are not happening, so the value for them is 0. So eventually, I have a vector. This is my feature. I will provide these features to the machines to do the classification. And then, of course, there are different libraries that I can use to do lots of different classification algorithms like KNN or naive Bayes or even SVM, or maybe some other voting classifiers or decision trees. So those are lots of different algorithms that I can use. And in this problem, I used all of them to figure out which is performing the best. And let me share the accuracy rates, how it looks like. In this case, I had class 1, 2, 3, 4, which is basically 4 different levels. But class 1 was the highest priority, like including the human life issues. For example, if I have some hardware components in my system, and if there's a current leakage, for example, it could lead to some harm or damage in human body. So in this case, in this real project, I didn't have any high class 1. So actually, I have 2, 3, and 4 labels in the real bugs reported by different people. So among these three classes, when I do the bug classification, this is how it looks like. And the overall accuracy rate was 73%. So it is kind of acceptable, but not the perfect rate. So what I did as the next step is, I thought that maybe I could merge 3 and 4. Because why I'm doing this? Does it make any sense? Yes, it does. Because in my project, the class 2 bugs were the release blockers. If I have some class 2 or class 1 bugs above the class 2, 1 and 2, were the release blockers. So if I had any of those, I would be blocking the release. I would not continue. First of all, I would fix them and then continue with the release. But otherwise, if I have 3 or 4 or any other, then I would continue because I thought that they were some risks that I can take, I can go with. So it is good to go for the release. So it is important to understand if a bug is class 2 or not, doing this classification. So 2 or not means class 2 is one class, and class 3 and 4 and all the others is another class. So by separating this is much more balanced, because what was the problem in the previous, let me go back to the previous slide. This is not much more balanced, right? Most of the labels, most of the bugs are labeled with class 2. So there's a bias on class 2. So this is why accuracy was a little bit low. But if I merge class 3 and 4, it is much more balanced. And this time the accuracy rate is 82%. So it is still not as the expected levels for a machine learning algorithm. But it's a difficult problem because, as we discussed, even for the human beings, sometimes it is subjective, right? It might be 72 for some people. For some other people, it is 73. How can we decide? So it is never possible to make 100% a consistency. But of course, what we can do is 82% is already acceptable to the initial classification. So in this way, maybe I cannot maybe let machines do triage for the final decision, but I can already facilitate and fasten the speed of classification. So this is a very hot and trendy topic, right? If machines can replace us. So maybe the answer is maybe not fully we can replace, but of course we can do a collaboration. Why are we trying to replace the human or the manual efforts in the project with machines, right? Why not we are trying to collaborate with them? So in this way we can maybe even achieve a more consistent way of doing our processes, or in a faster way. And not only the classification, but of course we can do some clustering algorithms as well. So in this way we can try to understand which bugs are having some or heaping together in some similar groups. So we can do the assignments or the managing of those bugs maybe in a simpler or easier way. So I'm wrapping up. So we discussed a lot about managing the bugs. First of all, we discussed what kind of communication channels we can maintain to talk to bugs. In the first place, what does talking to bugs mean? First of all, asking the correct questions and listening to them to get the correct answers. Because when we ask some questions, they will say lots of different stories, and they will provide us lots of different information. But we should be smart enough to listen to them and try to understand what they are saying. We should learn their language. We should be communicating in the proper way. And then we can collect lots of different information. And we discussed what kind of information we can collect from them. We discussed that we can use lots of different graphs or charts showing different distribution classes, or maybe just trends to show the numbers are going high or low in our environments. And finally, in the last part, maybe as a bonus part, we discussed how we can utilize machine learning algorithms to do our bug management processes. So I guess we have a little bit time to go over the questions if there are any. So thanks for listening to me. And if there is any questions, please do not hesitate to reach out to me, or just in the remaining time, just raise your questions, please. I guess there is one over there.
There's a question. Did you integrated your ML classification actually in your Jira projects?
Yes, I do. But again, as I said, I was not using this as the final decision, but I was just getting the results from the ML algorithms, and then I was just kind of cross-validating the results coming from machine learning algorithms with the results that were manually labeled by the creators of the tickets.